Hello everyone. Today we are covering a very important concept in soil mechanics, that is compaction of soil. This topic is very relevant for both field engineers and students who are preparing for competitive exams like GATE Engineering Services Examination and other competitive examinations. So let's jump right into the topic today. So what exactly soil compaction is? In simple terms, compaction is the process of increasing the dry density of soil by reducing the air voids in it. This is usually done using mechanical equipment such as rollers or rammers. Now, don't confuse this with consolidation. Consolidation is a slow process that occurs over time due to expulsion of water from a soil under a sustained loading. It is like the settlement you see in clay soil under a building, which takes more time. On the other hand, compaction is a quick process achieved by applying external force to pack the soil particles closely together. A very common example of compaction is that what happens during road construction, where heavy rollers are used to compact the subgrade soil to make sure it can bear the load intensity of the traffic safely to the ground surface. So, why is soil compaction more important? There are several reasons. It increases the strength of the soil. It reduces the futuristic settlement, making the structures more stable. It lowers permeability, so water doesn't seep through easily. And overall, it improves durability of roads, embankments, foundations, etc. Without proper compaction, structures can suffer from uneven settlement, reducing bearing capacity, or even complete failure may occur over time. So, in order to prevent the failure of soil, compaction of soil is more important. In order to study various compaction characteristics of the soil in laboratory, we usually perform two tests, namely standard Proctor test and modified Proctor test. These tests are standardized tests used to determine the maximum dry density of a soil with respect to a particular moisture content, that is optimum moisture content, which is termed as OMC of the soil. As far as standard Proctor test is concerned, we use a rammer of 2.5 kilograms to compact the soil in 3 different layers inside a mold. Each layer is given 25 blows. Whereas in modified Proctor test, a heavier weight of rammer 4.5 kilograms with a greater drop height, that is 45 centimeter, is used to compact the soil in case of highways or airport runways, where the subgrade soil strength should be maximum. It is used when we want to stimulate heavier compaction, like what you would find under highways or airport runways. Both tests help us to figure the best amount of water to use for effective compaction and the maximum dry density we can achieve for that soil with that amount of water content. So when you plot the dry density versus moisture content from the compaction test, you get a curve called compaction curve. In this curve, at first, increasing the moisture content helps particle rearrange and compact better, but after a certain point, too much of water starts to take the space and the density actually begins to drop at particular stage beyond the optimum moisture content. The point where you get the maximum dry density is called the optimum moisture content, or OMC. This is the sweet spot we aim for finding the field compaction. Now let's talk what happens on the site. To compact the soil in the field, we use various types of equipment and rollers, and among them are smooth wheel rollers, which is used for granular soils, sheepfoot rollers, greatly used for cohesive soils such as clay, and pneumatic rollers or rubber tired rollers use compress air for better pressure. And the most widely used rollers are vibratory rollers, which apply vibrations for deep compaction. We also verify compaction in the field using simple tests such as core cutter method for soft cohesive clays, sand repletion method for dry and hard soils, and nuclear density gauges for modern, quick and very hard strata, which is quite expensive. There are various factors affecting the compaction of soil. These are soil type, clay soil, sand and silt all behave differently. A soil having maximum amount of clay is very difficult to compact, whereas the soil having sand, silt and gravel content is very easier to compact. Next factor is moisture content. Too little or too much water will reduce the compaction. And most important thing is the compactive energy. More amount of energy required for compaction produces better compaction. And also the layer thickness. Compaction in thin layers is recommended for best results. And also finally, weather condition, rain or heat can impact the compaction quality to a greater extent. To sum it all up, compaction increases dry density by removing air content. It is essential for strong, stable and safe foundation. Proctor test help us to find OMC and MDD, which is a representation of various compaction characteristics of soil. And proper field methods make sure that compaction is achieved at a greater extent, and the soil is more suitable for construction of heavier structures such as roads, embankments, airfield pavements, etc. So thank you so much for watching this lecture on compaction. If you find this helpful, give a thumbs up, share it with your classmates, and subscribe for more easy understanding of various civil engineering content. Until next time, keep learning and keep building. Thank you everyone.